Alright, welcome to Lecture 4, Graphical Representations of Reaction Kinetics. This is a continuation of our unit on chemical kinetics. In this Lecture 4, we will be focusing on graphs of zero, first order, and second order reactions. We'll be looking at different viewpoints of these graphs and so forth. So first of all, let's draw some graphs for a zero order reaction of concentration versus time and rate versus concentration. Okay, so we're going to take a graph here, and because zero order has the rate law of a to the zero, all right, for a zero order reaction, therefore the rate is really equal to K. And so if we have the concentration, so concentration of A on the y-axis, and we have time on the x-axis, then when we graph this, we should get a straight line like this with the negative slope. That is because the rate is equal to the rate constant K. Alright. And that will give us a straight line path. Alright. Now, if we draw another graph of showing rate versus concentration of A, right? Then we should get a straight line going across like so. Alright, and so that would be what a graph would look like with rate versus concentration. So you need to know what these graphs look like for zero order, first order, second order, as far as concentration versus time and rate versus concentration. Alright, so there is a zero order. So let's look at a first order. Alright, first order, it's a little bit more complex because we have our rate equation is rate is equal to K A to the first order. Alright, so if I was to have a, over here's concentration of A and time, if I was to graph, make a graph of this rate law equation, it would look something like this, an exponential, like that. And that would be for first order, concentration of A versus time for first order. Now, what we can do is many times is we want to make this a linear graph, alright? So instead of having an exponential graph, we want to do concentration, and to do that we have to take the inverse log of the concentration of A over time and that's going to help us to get a linear line like so. Now this graph is derived from a specific equation, alright? And so the equation that we derive this from is going to be the natural log of A at some time minus the natural log of A at the initial concentration, and all of this is going to equal to minus kT. Alright? And so this equation right here is going to allow us to graph the natural log of A versus time to get us a linear line. And so make sure you write this equation in your notes and know it really well. Alright? Now, now we need to graph a first order of rate versus concentration. Alright? So we just did concentration versus time. Now we need rate versus concentration. And if we did that, rate versus the concentration of A, we would get a linear line like that. Okay? For a first order reaction. Alright? So these graphs for first order, make sure you know, have them in your notes. And then the last graphic representations we got to look at are for second order reactions. So again, we're going to start out with looking at concentration versus time. And so first of all, remember that we have the rate law for a second order is equal to K A squared. Second order. And so if I was to graph this, actually let me write this a little different. Okay, you're going to have concentration of A over time. You are also going to get a downward curve, but it's going to be much steeper than you see for a first order. And if we were to linearize this equation, then we would do 1 over, let's make this a little different. 1 over concentration of A time, we would get a linear plot that looks like this. Alright, and so if we take our exponential curve here, this one, and we were to do 1 over A, or 1 over the concentration time, we get a linear plot or best fit line. Alright, now the equation for this best fit line, which you need to know, is 1 over A time t minus 1 over A initial equals KT. That's for second order. And this equation here is going to allow us to plot a best fit linear line like that. Alright? Alright, so there's that. Now we need to do rate versus concentration for a second order. And that is simply going to look like this. Rate over concentration of A should get us a exponential like so. Alright, for rate versus concentration. Alright, so there's second order graphs that you need to know. Now to summarize all of this then, is if we were to look at this, we'd have concentration of A over time. Let's summarize this. Okay, for zero order, you would get a straight line. That's a zero order. For first order, we would get something like this. That's a first order. And then for a second order, we would get a much steeper curve like this for second order. Versus, and that's concentration versus time. Alright? Alright, now, as far as the summary for rate versus concentration. So rate versus concentration of A. Right, here we go. So for zero order, it would be this. For a first order, it would be this. First order. And for a second order, it's going to be that. Right? So there's what it looks like in summary of all this. Alright? So all you need to do is make sure you know these graphs really well, be able to recognize these graphs that they give you on the test, draw them, and so forth. For the quiz that we have in class, I will expect you to know these graphs for zero, first, and second order reactions. For both concentration versus time and rate versus time. Alright, so that is all there is to this lecture.